Hey guys, I want to talk to you guys about recursion. Hopefully a video helps you out. So we're going to do pretty much one of the easiest recursive formulas is factorial. Factorial, if you ever have seen it before, it's just this right here. So 5 with an exclamation point after it. And that is equal to 5 times 4 times 3 times 2 times 1. That should be 120. And actually the mathematical formula for that is k exclamation point equals k times k minus 1 times k minus 2 times k minus 3 all the way up until k eventually gets to 1. And this is for all positive integers, whatever. But I'm just showing you what a recursive formula looks like, because you've seen formulas where n plus k is, you have those numbers. Here we don't have those numbers. We only know k. And so we're going to use recursion and the call stack. The call stack is going to help us understand how recursion works in programming. So this is our function. It's called factorial. This is where we're going to start, right? We input a k. We have our base case. So the base case handles this part right here. Handles this part when k eventually gets to 1. Because when k eventually gets to 1, we know that. We know the answer to that. We know that it should return 1 once k equals 1. So this is our base case. This is when the factorial actually returns. This is the first time factorial is going to return a real value. This is the base case. Here is the recursive case. This is the recursive call, recursive case, whatever you want to call it. But pretty much for every other time for this section and so on, even beyond, you could call k of 100 and it would have to go back 99 times to get to 1. So if you called k of 100, 99 times it would go through this. And what is this? You're saying take k, take the original k here, and multiply it by factorial of k minus 1. That's this right here. And then when you call that, the new k is this k. And that's going to come in, and it's going to do it again, and it's going to be this. Because k minus 1 is k minus 2. So that's this part. It's going to keep on going, but it's not going to know the answer. It's going to keep on calling itself. It's going to keep on calling itself. And what am I getting at here? It's the call stack. We're looking at the call stack. And that's why part of day 2 was to learn the call stack first, because recursion is going to be extremely difficult if you don't know what the call stack is. I drew an example of how this works. First, let's run the function. We're going to run the function with 5. I'm calling it here factorial of test, right? So if I run node factorial, it should be 120. And if you do, let's see if this 5 factorial, it's 120, right? Now, let's see if you look grows very fast. Look at 8 factorial, 40,320. Okay, let's try factorial test 8. See how that comes out. 40,320. So this is working. It's actually working pretty fast, right? There is no true mathematical formula in here except to just call the one behind it. Call the number that immediately precedes it all the way up to 1. And so it's working. This function kind of works backwards. Recursion kind of works backwards. And you remember the call stack, right? The call stack happens when this function, even though it was the first to be called right here, because this is the first one, this is with factorial of 8, it's the first to be called, it's the last one to run. Okay, try to get that. So this is the image of factorial of 8. This is the first function call. It's a stack. Remember that. These are the walls of the stack, right? You're putting things in. This is your stack of folded clothes, and you're putting the first piece of clothing down, you're putting the next piece of clothing down. This is the first function call. The first function call, factorial, is going to look at 8. It's going to say, hey, it's not 1. We need to do this. So it's going to call this. It's going to put k minus 1, which is 7, on the stack, and then when it gets to 7, it's going to do the same exact thing. It's going to repeat up the stack for 6, for 5, for 4, for 3, for 2, for 1. And now, when it gets to 1, it's going to say, hey, I know what 1 is. K equals 1. I know what 1 is. So I can start, I know what it is. I'm returning 1. So this function returns and comes off the stack. It finishes and it goes, hey, I know what 1 is. It's 1. So it returns 1. And then it comes out here in this function call. This actually, I should remove it from the stack. This comes off the stack, and now it's this one. Goes to factorial of 2, but the 1 returned into this function. And what does this function do? It multiplies what it had, its k, which k equals 2 here, times the return value of this, which is of this factorial k minus 1, which is, it knows what it is now, it's 1. So it goes 2 times 1 is 2. This comes off the stack. And we know because it's 1 times 2. Well, I'll write it the other way, the way it's in the return value. 2 times 1. This goes 3. What's 3 times? This returns 2 now. This equals to 2. Equals to 2. Comes off the stack. The 2 goes to 3. And it's just a simple 3 times 2, because this is what was in the function, and this is the return value from the one before it. This is going to be equal to 6, and you can see the pattern here. 6 times 4, 24, you get. This is 24 times 5 is 120, right? And then you just start getting immensely, this starts growing really fast. But you could see how the next one is 120 times 6. Whatever the result of 120 times 6 is, this one knows that result, and it's because this is it. This is all the mathematical expression right up here. So it's going to return that until finally it gets to the very last part of the stack, and it pops off. Again, to reiterate, this is the first function call. Recursion starts building, boom, 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 until somebody, one of them, knows the answer, and it gives the return value, and then it starts coming back down the stack. Boom, 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 boom. And that is recursion. I hope this video helped. Thanks a lot, guys.